Let me just make sure all the streams are started, and then we'll be ready to go. Right, well, good afternoon, everyone. Let's get started then. Welcome to today's webinar, which is building intelligent apps and smart AI integration with MCP. Those of you who have obviously seen the communications from 345, you know me. I'm Andrew. I'm a founder of 345 Technology, and I have with me Mark Harrison from Microsoft. And Mark's and I always get this wrong, App Innovation Specialist. Do you want to just sort
That'll
of
do. Yeah.
say a little
Actually,
bit about
app inno-
what you do, Mark?
yeah, so the official title is App Innovation Specialist. I also think it's a developer specialist role, and it's all about helping our customers understand the why and the how in using Microsoft platforms to run their applications. That's me.
Great stuff. And of course the big thing at the moment is getting things is how can we actually take advantage of AI, and how can we build AI into our apps to make them more intelligent? And that's the subject of today's webinar. So um, without further ado, I think we can just start getting kicked off and setting the scene with to today's topic. So Mark, do you want to kick us
Yeah.
off?
So let's go with this. So artificial intelligence, it's influencing today's software development in two ways. There's building software using AI and building AI into software. So the first one, building software using AI, it's using things like GitHub Copilot. So it's acting like a peer programmer or assistant. It's making recommendations. It's kind of reducing the developers' think time, which is reducing their keystrokes, and it's just providing this kind of learning assistant. And then the second one is like building AI into software. So it's to enhance its capabilities and make apps smarter. And of the two topics, this is the one that we're going to drill into today.
Great
So,
stuff. So, so
yeah.
yeah. So I mean, I think one of the other things we'll just point out is as we go. Sorry, Mark, I know you're just getting in the flow, but
No, you go for it.
yeah. But one of the things I was just going to say is that we're going to try to make today's presentation a bit, quite conversational. So we'll just chip in as we go along. Um, but that's but that whole thing of, I think one of the things we're going to try to demonstrate is obviously how the whole, how these apps fit together, but also how some of the things that we do anyway, like APIs and how and data and how we get those incorporated. It's APIs build, the intelligent apps build on the things we've got already. It's not like suddenly we're landing on another planet. It's the fact that we've got some great tools here to actually get more out of what we've already got. I think it's just important to kind of set that context that it's an evolution of applications rather than it's somewhere that's just completely on another planet. That's so
Yeah,
sorry, Mark.
yeah. So it's no. So it is an evolution, but I kind of think of it being, as this kind of graphic says, it's the new baseline. So a couple of years ago, we were talking modern apps were about things like DevOps and cloud native architectures and building resilient code and APIs and integration, which I know that you're very fond of, and then always about reducing technical debt. The baseline has now changed, and it's all about infusing AI into your apps to make them smarter, enhance their capabilities, improve automation, smarter decision making. Now, the AI services that we'll look at, it's all very clever, but on their own, it's not enough. You do need software engineers. They're key. They're going to implement the business logic around those AI services to achieve the goals and deliver intelligent applications. So, at the core of intelligent apps is artificial intelligence, but AI itself isn't new. Technologies like machine learning, decision systems, robotics, they've been evolving for years. But then in the last couple of years, Gen AI has burst onto the scene. It's unlocking entirely new possibilities, and it's a bit of a game changer. It's really expanding AI's potential and redefining what's possible. And there's two terms that we're going to drill down into next, Andrew. They're AI agents and agentic AI. And they're often, or sometimes they're used wrongly. So
Well,
whilst they
do you know
sound
what?
similar,
I still,
yeah,
whenever I talk to people about this, people just say it's the same thing, isn't it? Isn't agentic AI application,
they're similar, but they refer
applications
to
with the
slightly
AI?
different concepts.
So it'd be really
Yeah.
good to clear that one up because it's so hard
Yeah.
to have a conversation with people when they don't quite get the difference between those
Yeah.
things.
And people do tend to use it wrongly. So let's kind of break it down. So an AI agent is a digital worker. It's a system that performs specific tasks, reacting to inputs and following rules. So an example might be a customer service chatbot. So it can handle routine queries like maybe account balances or paying bills. They follow predefined scripts to provide answers and complete tasks, and they reduce the need for human intervention. So they're pretty good at managing repetitive, simple tasks efficiently. Agentic AI goes beyond following fixed rules. So it can think and adapt and make independent decisions. So it's kind of actively learning, and it's adjust its approach and strategies to solve complex problems. So let's think of some examples. So in scientific research, an agentic AI system could analyze vast data sets and come up with its own hypotheses and run experiments to redefine its understanding. So, pharmaceutical companies are using this for drug discovery through molecular simulation, rapid screening, and analysis. And they can do this at a kind of speed and accuracy once considered impossible. So it kind of makes agentic AI much more powerful, capable of solving the hard problems and kind of driving innovation. Is that any kind of
Yes,
clearer between the two?
I think it is. I mean, let's say an AI agent is effectively because if you look at what people commonly see as a chatbot, that needs AI in order to understand the human input. Um, but but behind it, its brain isn't really AI. It's using AI to to parse the input and that sort of thing. But it's like you say, it's actually more deterministic in terms of what it does. Whereas an agentic AI, you're more saying, here's the problem and setting it loose to try and solve the problem, and it's doing it's finding its own way to do that without actually, um, without having its own algorithm tightly controlled. So that's my wording for it, but I don't know if that makes it any clearer for anyone.
That sounds good. So just another term just to throw into the pot, multi-agent systems. So this is kind of breaking breaking down the complexity of a single agent into smaller agents, specialized agents. It's a little bit kind of akin to microservice-based architectures. You're breaking this complex problem down into smaller units of work, and it allows those kind of agents to specialize on what they're good at. Also, like microservices, there is this challenge of how do you coordinate and communicate between the agents. There is this new protocol A2A. It's only published in April, and Microsoft are supporting this, and we're going to start to see this into all our products. Let's put it all what we've covered into an example, and in this case, a smart building. So an example of an agent could be a temperature control. You turn the heat, it turns the heat on and off, and its role is to keep the temperature within a range. A multi-agent system could have multiple instances of this temperature control agent, but it could work with other agents, maybe managing air quality, security, lighting, elevator maintenance, maybe water management, occupancy detection. So together they are optimizing the building's performance. Now remember, agentic AI doesn't follow preset rules. So it's learning from the building's historic data to spot patterns and then adapts in real time to optimize things like energy use, air quality, carbon footprint, and comfort. So over time, it predicts and adjusts itself, all in advance of any kind of potential issues arising. So that I always think is a good example of the different things in together. So
Yeah,
we're kind of
and those sorry, man, just to clarify that
no,
those
no, go for
agents
it.
are that those agents are just worried about the one thing, whereas the agentic AI can be trying to optimize a whole bunch of different parameters at the same time and just have it's just a more holistic view of the whole problem.
So when it comes to agentic AI, it's still evolving. The first wave of agents are common today, and these do things like retrieve information from grounding data. They can reason, summarize, and answer questions. They can generate content. They can take actions when asked to. So automate workflows and eliminate repetitive tasks. It's the second wave of kind of autonomous agents that is becoming the new frontier. It's kind of emerging and it's where customers' needs are and really where the focus is moving to. Okay, we're going to now start drilling down into the kind of architecture of an intelligent app. So there will be three tiers. There's the app itself, there's the front end client. Now that could be a user interface or it could be another system. And when it's a user interface in Microsoft, we would talk about that being a kind of co-pilot. So, the buzzword is co-pilot is the UI for AI. And then we've got the back end services, and we can think of them as two main categories. There's the AI services and there's the non-AI services. So that could be something like a weather API or a calendar API. Within the AI services are foundation models, search, vector stores, and cognitive services. And we're going to look at each one of those. Then the other thing on the left hand, this graphic is showing responsible AI. So these are all important topics and kind of essential because it builds trust, it prevents harm, and ensures technology benefits everyone fairly. So what we're going to do is now drill down into those AI services. Start first with foundation models. So these are AI systems designed to handle tasks by learning from large data sets. Once trained, they can be used with new data to do things like make decisions and generate content. So an example of this would be when it's trained on text, they can understand and generate kind of human language by identifying words and context and grammar. So there are powerful models like large language models. These require significant computer resources and they run in the cloud. And on the other hand, there's these kind of smaller versions of these models that can run efficiently on devices with less processing power, making them good for kind of localized real-time tasks. At the bottom, you can see there's a lot of different kind of models. And there's an explosion of the number of models, and it's really hard for everyone to understand which are the best models. And even within a family like OpenAI, GPT, there's GPT-4, 4.1, 4.5, there's the O3 model, there's the O4 model. It's really hard for people to understand which is the best model for a particular task. Thoughts, Andrew, on that? Are you seeing this
Um,
complexity, just the number of models there are?
I mean, I think the complexity of models is such that people generally are finding the one that they're comfortable with, like like the GPT-4, and just kind of just sticking with that. I don't think they're, I think it's a sufficiently daunting problem to look through even that list you've got there and to say,
Mm.
what's the best model for my task? And I think that's a kind of from a consumer point of view, that's a really hard area because how are, how are people going to know which model they should be using. I mean, I can understand from the provider's perspective, the commercial opportunity of being the model of choice is absolutely vast. But
Yeah.
if you're in the AI model shop and when you want to pick one off the shelf and use it, I think that's where a lot of people are
No,
really struggling at the
it
moment.
is it is a challenge. They are evolving all the time. The other interesting thing that was announced of build is like the GPT. I think it was the 4.0 is reduced 97%. Is it 97%? It's either 97 or 93% over the last 2 years. But it's a huge, huge drop in the cost of using it.
Yeah.
Okay, the next one.
And yeah, go on.
I was going to just talk about search. So the search is pretty key in this. There are two kind of types of search. There's keyword search and there's semantic search. The best way of seeing the difference is looking at the examples. So keyword search is just matter. The query is how does global warming impact nature? So a keyword search matches on the exact words, whereas semantic search kind of understands the whole meaning of the query. So something like climate change affects biodiversity would match with this query. And the way it does it is something called embeddings. So let's drill down on what embeddings are. So we're all used to thinking in two-dimensional, three-dimensional space, and we visualize X, Y, and Z axes. Embeddings are about encoding complex data into vectors with much higher dimensions. Sometimes there are even like hundreds or thousands of these dimensions in the vector. So you can find the similarity between two items by measuring their distance from one another using an algorithm called cosine similarity. So we can picturize it if it's just 3 dimensions, but it's a lot harder to kind of get your mind wrapped around it when it's like hundreds of dimensions. But the example there is, how do I fix my phone screen? Might map to and it is just an example. It might map to those numbers. And what is the best way to repair a broken phone screen? And you can look at those numbers and they're pretty close. So they're a good match. With something like what is the weather today, there's nothing about phone screens, there's nothing about repairs in there. It's in a completely different vector space. So it's not a close match. Another example is medical images. So you can take chest x-rays and you can vectorize them, and then you can see that certain conditions in an x-ray image, they would cluster together. So if you could bring a new image along and you can actually run it through an application and maybe detect conditions in that x-ray that would be hard for a human to identify. Now you can store these embeddings in a vector store where you can kind of store them and retrieve them. And again, I've kind of listed some of the potential vector stores. So we've got the Azure ones, AI Search and Cosmos DB, SQL Server, and there's a few other ones as well. The next one is cognitive services. So these are cloud-based APIs that allow developers to embed AI into their applications without being an expert on AI. So, for example, if you wanted to embed some sort of speech or kind of language translation into your app, you can just call on these services. I've listed the Azure portfolio of services, and you can see it's quite a comprehensive list. Um, but it just makes it simple. Without being an expert, you can embed AI into your apps. So, any thoughts, Andrew? We're going to drill down into patterns next.
Um, I think one of the things that's interesting there is that a lot of those, it's amazing how quickly a lot of those type of things are just becoming normal. In that instead of people thinking, oh, there's that cognitive service for AI vision, it's just like, in the Photos app on your phone, it recognizes people. You know, it's it's almost that once you take the sort of the technical aspect of it out, and it's like what you're trying to do. Actually, people are finding this all over the place now in their everyday life, and in fact, with things like you know even just speech to text, dictating your text messages. It's these are these functionalities that are almost like in everyone's phone. Underpinning those, there are these cognitive services. And it's I think the more that we the more that we talk about what is it we're trying to do, and actually there's a service that solves that problem, I think that kind of demystifies it for everyone. Um, and there are there's just a whole load of even just speech to text of instead of taking meeting notes, you can just have an AI agent that does that for you and then puts it through another language model to summarize and get the key points and the actions. These are there's some really powerful stuff being built on these foundational services, but we just but when we just see the useful things that come out of it, it makes it a lot more a lot clearer for people.
Indeed. Okay, we're going to talk about some patterns now. So the first one I want to talk about is the kind of the chat pattern. So this is a kind of conversational interaction flow between an application and a AI system. So in the first message, you have a system prompt, what you want the agent to do, or the AI endpoint to do, and a user prompt, what you want to do. That's sent up to the AI endpoint and it sends back a response. That response is then added to the chat history. Then subsequent messages include a new prompt, but it's also the whole history of the previous conversation so that the AI endpoint understands the conversation that's going on and can make a response based on everything it knows about. Now, one of the challenges is these AI endpoints, their trained model only knows knowledge up to a specific date, and it's typically trained on public information. Now you can fine tune these models and extends it with domain knowledge to kind of better align to a particular goal, but it is computationally expensive to fine tune a model. So an alternative to fine tuning is the RAG pattern. So the idea of this is when you want to do uh, make a query on the endpoint, what it can do is it can get some knowledge to augment the chat history. So um, you can ask something like maybe Bing or SharePoint or AI search. This is what I want to do. Have you got any information about that subject? It will take that chunk of information, add it to the chat history, and then send it to the AI endpoint to make a response. The next kind of pattern is what they call kind of tool and function calling. So when you send to the AI endpoint the chat history, you can also let it know about any tools that you've got available. So what it can enable the AI endpoint to make a decision that it wants to perform actions or retrieve data or execute code by calling those tools. And as you can see, Andrew, there's the AI integration services. They're all tools that could be called upon. So um,
Yeah, and this again, this is where it kind of what these are what then become the bread and butter things that we actually do. That of how that we can hook in the APIs, we can hook in things like logic apps that allow you to do process logic and transform data and merge different data sets together before taking it back to the AI app. So it's this is almost where it just where we get into like normal development, but that actually really complements the whole AI picture.
and we can put it all together, and we can have chat and RAG and tools in the same application. So as part of the conversation, we can augment it with not local knowledge, um, domain knowledge, and then the AI, based on what it's thinking, it might want to invoke some functions to do some action. So okay, let's go back to this diagram, and we've kind of added the AI services on here. Now, a question is, when you're writing applications, how do you reduce the amount of code that you use in your applications? And the answer to that is use a software library. Why write code if somebody's already done it for you? Just reuse that code. So when it comes to AI, there's several software libraries that can help here, but the Microsoft solution to this is a framework called the semantic kernel. By embedding that into application, again, it's just kind of reducing the amount of code that we need to write for an intelligent application. So semantic kernel, it's this open source, lightweight, extensible. It's built for enterprise developers, so it's supported, it's trustworthy, it's reliable. The semantic kernel team will make sure that they don't make changes that will break the applications. There's support for these languages. There's .NET, there's Python, there's Java, and these are the items of functionality that it includes. So there are connectors to AI services, and it provides this abstraction layer. What it means, if you want to change something, like you want to change your AI model, you just switch out the connector. You don't have to change your application. There's functionality to handle context and prompts and plugins to extend the functionality. That is to call the tools that we saw on the pattern slide. There's telemetry to observe what's happening. And within this semantic kernel, there are two frameworks for handling or developing multi-agent applications. There's the agent framework, which allows the large language model logic to decide the workflow. And then there's a process framework, which is like an event-driven workflow process. So let's go back to this diagram, and we'll now put the semantic kernel into our diagram. Let's let's talk about these AI services. So they actually, in the Azure world, we actually surface them up in a platform called the Azure AI Foundry. So let's just update that. So AI Foundry is providing this complete AI toolchain as a single platform, and it contains a suite of AI capabilities and models and tools for developers to design, customize, and manage their AI applications. There is let's just call out one of the features within here is the AI Foundry agent service, and it's a managed platform to host agents. Now, what it means is we can offload some of the agent processing out of our intelligent app into this managed service, which just makes it easier to take to production. If this application is a heavily utilized application, by moving a lot of the logic out into a managed service, it just makes the whole task of scaling this up much, much simpler. I just want to call out so we've introduced Azure AI Foundry. I just want to call out that Microsoft does have this kind of spectrum of tools for building AI applications. So AI Foundry is targeted at the developer, the data scientist, and it's got full flexibility and control. Whereas the Agent Builder and Copilot Studio are kind of zero code, low code tools with a kind of managed software as a service stack. They enable rapid authoring and time to value. But it's not like Copilot Studio versus a Foundry. There is a lot of interoperability between the two. So, for example, you could extend Copilot Studio with services from AI Foundry. Okay, we're going to now demo. So I'm going to switch over to you, Andrew. What we've done is we put the demos into videos just to make it a lot snappier. So
Yep, just bear with me a moment. So do say if you have any issues hearing this, but
So
it
let's
should
take a
all
look
come
at
through.
AI Foundry, the complete Azure AI toolchain, all integrated within a single platform. It's organized hierarchically with hubs, and within each hub you have projects. And from the menu you can see there's lots to explore. Includes functionality around building, observing, and governance, which are all great topics for a future session. It includes the Azure portfolio of AI services like speech, content understanding, translation, video, and content safety. Let's first look at the model catalog. Here you can see we have access to over 11,200 models. That's a lot. How can we see what we really need? We can filter on various things, such as vendor, industry, deployment options, and inference tasks. There is also an agent to help us navigate the catalog and choose an appropriate model. And we can compare models, look at things like quality, accuracy, costs, latency, and so on. At the top, we've got various announcements from the AI Foundry team. One new announcement I can see, Grok 3 is now available in the AI Foundry. I can select the Grok 3 model, hit the blue deploy button, follow a few more dialogues, and Grok 3 is then available for me to use. If I click on My Assets Models, I can see what models I currently have deployed in my project. One model I have deployed is GPT-4o. If I click on this, I can look at various properties and information about its deployment. If I click on Agents in the menu, I can then see a number of AI Foundry agents that I currently have configured. Click this blue button and I can create a new agent. Give it an agent name. I then select the model I want to use. In this case, I'm going to use GPT-4o. I give it some instructions, the system prompt. I can point it at some knowledge so it can ground its responses. For example, I could have some information in some files, or if I use Bing, it can have got access to the whole of the internet. And I can point it at some actions, enabling the agent to perform tasks, typically by invoking code or APIs. Let's now look at each agent in turn and see how I've configured them with various items of knowledge and actions. I have a vanilla agent. It's a helpful assistant, but it's got no access to any knowledge or any actions. I have a Bing agent, similar to vanilla, but it's got access to Bing, and so can access the latest knowledge from the web. I have an Alan Turing agent. It's set to "You are Alan Turing, speaking the first person." And it's using knowledge from a series of documents that's got all sorts of information about Alan Turing, such as his personal life and his achievements. I have the Titanic agent. It's got access to an Excel spreadsheet and has got information about travelers on the Titanic. I have an agent called Trailmaster. It's got some knowledge about camping information that is stored in Azure AI Search. I have an agent called Colors. It's got knowledge of an API service that can store and retrieve color information. So we have to give it the Open API or Swagger document. And my last agent, it knows about a Logic app. It can use Microsoft 365 to send an email. Let's now see these AI agents in action. I've created a simple web app that lets me connect to an agent and have a conversation. The code for this app is available on GitHub at markharrison/AI Agent Web. In the app, there's a menu option to view files I've uploaded to AI Foundry. Here we can see the knowledge files on the topics, Alan Turing and the Titanic passengers. Another menu option allows us to create an agent. I can do this either through the Foundry portal UI or by writing code directly. We can also list all available agents which match the list we saw earlier. There's an option to chat with an agent where we get a list of agents to choose from. For this demo, I'll select our vanilla agent. To connect to an agent, we have to create a thread. Essentially, this is a running instance of the agent. I'll ask it, who won the most recent FA Cup? Since the agent's knowledge only goes up to the training cutoff date, it provides the 2023 winner. Now let's try again using the Bing agent. This one knows about the 2025 winner and even provides a link to the relevant web page. Now let's have a chat with Alan Turing. Notice how the agent responds in the first person as if it was Alan Turing himself. Now let's explore Titanic survival data. I want to create a bar chart to visualize survival rates by travel class. We can see that 62% of the first class passengers survived, while unfortunately only 25% of the third class passengers did. Next, let's take a look at the agent that can interact with our Logic app, specifically the one that can send an email. I've asked it for an inspirational quote and indicated that I'd like it emailed to me. The AI agent recognizes that it has access to an email sending tool and it uses that. Let's wait a moment. Here it is. The email has arrived. Thank you, Steve Jobs, for your words of wisdom. Now let's take a look at the run history of our Logic app. As expected, we can see the same quote logged in the workflow. Moving on to our final agent, this one interacts with our Colors API, which stores and retrieves color data from a database. The code for this API is also available on my GitHub if you'd like to explore it in more detail later. One of the API operations lets us list all stored colors. When we run it, we see various shades of blue. There's another option that returns a random color. In addition to the API, we have the Colors web app. Again, the code is on GitHub. This app features a series of lights that at random intervals will call the API to retrieve and display a random color. As we watch, we can see different blues flashing across the lights. Now let's try using our agent. I've asked it to find the color of Watford FC's shirt and store that color. The agent knows that it has access to the API and it uses the appropriate tool to store the new color. We can see that yellow has now been added to the colors database. And we can verify here that yellow was added. Now, let's return to AI Foundry. There's a tab that displays all instances of agent threads where we can see the full message history, the conversations exchanged between the user and the agent. If we drill down into a specific thread, we can get even more detail. Here we can see which tools were invoked and the parameters that were passed during the execution. For example, this is where the color database was updated with the color yellow. In another thread, we can see the activity related to generating our Titanic survival chart. There are two tool calls here. The first call retrieves the headers from the data file, helping the agent understand the structure of the data set. The second call executes the Python code to generate the actual chart. And finally, in this thread, we can see our logic app being invoked. Parameters passed to the app can be seen, like the email content and recipient. In the next demo, we have semantic kernel orchestrating multiple agents. As before, the code is published in my GitHub for later perusal. We've got three agents, a poet, a color checker, and a manager. The system's prompts tell each agent what they are to do. The poet agent is told to create a funny poem about a provided subject. The color checker agent is told to detect if the poem contains a color, otherwise it is tagged as a dull poem. The manager agent approves the poem if told by the color checker it does include a color. The code specifies a termination strategy, when to stop and also to avoid endless loops. And the code also includes a select the next agent strategy. The agent group chat binds the multiple agents to work in a conversation together to solve the problem. So let's run it. Enter a poem subject. Let's try Birds at the Zoo. The first poem is rejected. The second poem is also rejected. Ah, good. The third poem is approved. It includes the word pink. The termination strategy determines the goal has been met, and so the process terminates. I've written a simple MCP application with knowledge about colors.
I'd stop that one, Andrew.
There we are. Yeah, I've stopped that one. We're now
That's the next one.
onto the final one. So I'll stop sharing now for now, and then we can get back to the presentation. But I don't know where to start on that, Mark. There's just so much in there in a short space of time that we could dive into. But all the things you've been talking about, it really kind of brought those to life with a bit of,
Yeah. I
with
mean, there was a number of agents. So we were showing the RAG pattern where we were augmenting the request up to the learning model. So like the Alan Turing one, we asked a question, what did you achieve? And it can't send everything up, so it has to look, and that's where search comes in. It finds some relevant chunks based on your query out of your knowledge set, takes those chunks, includes that in the message up, and then you get an appropriate response. So we saw that, and then we saw taking action. So things like firing logic apps or firing open API based on what you're asking it for. So we kind of showed how those agents did those two that address those patterns, the RAG pattern and the tool pattern. Yeah. So
while we're just getting back to that, I've got a question in the chat, which is, what are the main factors that would adjust the consumption charge rate of using AI? Like, what models are more expensive than others, and how does using them affect the pricing?
it's all to do with these things called tokens. So whenever you send one of these chat histories up, it's broken down into tokens, which are it's not necessarily, a token doesn't necessarily map onto a word. It could map on, a word could be, if it's a complex word, it could be 3 tokens, and then it's basically counting the number of tokens, and that's what you're paying for. API management can actually, if you put that between it, it can actually help you kind of do token rating, throttling, and kind of audit your costs. But and then different models will have different cost per token.
Yeah, and that's a whole bit. I think we touched on that in a previous webinar about using API management with some of the cognitive services, so that you've actually at least got some traceability and governance on where your money's going with tokens, because it's the more that these things get built in, companies are really going to want to know who's who's running up the AI bill. So again, another topic for maybe outside of this webinar, but a really one that's really grown in importance.
Good question. If there's nothing else, could you enable me again to share? I don't know whether you spotted, I had to kind of quick reboot in the middle there. So I've had to reconnect, so I've lost the permission to share.
You should
Thank
be
you.
okay now, Mark. I did notice you. I thought you might have just turned your camera off. I didn't realize it was a reboot.
No, I had my machine just froze, the whole machine. I blame this go-to software, but anyway, let's go back to this diagram. Slightly simplified for what we saw. So we've got our intelligent app, we've got the back-end services. Now, when we talk about external services, there are potentially thousands and thousands of different back-end services, databases, and resources that you could potentially connect to. Now, if you had to accommodate each service that comes along, it could mean you need a new plugin. There's different endpoints, different protocols, different authentication rules. Each time you want to adopt a new backend service, do you have to go and rewrite or extend your app? Now, a bit of an analogy. Those old enough will remember the first PCs in the 90s and what a pain it was when you installed a new device, such as a printer or a sound card. And everything came really much easier when things like Windows 95 adopted plug and play. And then USB came along, which just made it such easy. You just plug in a new device, relevant drivers are detected, and it just works. What we really need here is a plug and play solution to our intelligent app where we can just plug in these back-end services without having to change our application. So we need a plugin and we need a common interface. And that's what MCP is solving. It's a protocol designed to enable intelligent AI applications to interact seamlessly with backend tools and services. So it makes our apps more intelligent. Now there's a link there to the protocol. These two links are interesting as well because it contains a catalog of MCP servers, and this is where you start to see there are many services out there that have now put an MCP wrapper around it to make it easy to interface to your apps. So your app, you have this plugin kind of architecture. You have all you need to do is support the client, and then it doesn't matter what backend service, as long as it's MCP compliant, your app can talk to it. Now there are actually two versions. There's two kind of protocols that one that when your client and your MCP app are on the same machine, but the alternative, the second one, is where it has to communicate because it's a remote service. So MCP supports both on the same machine and remote. And the nice thing is the back end part, the server to the actual service, this is maintained by the resource, the tool owner. They have to look after this bit, and all they've got to do is make sure that the front of their service is MCP compliant, and then we can just plug it into our application. So an app can actually talk to multiple MCP services. So we're kind of showing here the different types. It could be local, it could be remote. By the way, semantic kernel supports our intelligent app talking to, it supports a client talking to services, but actually our app itself could be the service as well. And semantic kernel provides an MCP client. To write this wrapper, there's an SDK, there's a number of languages, so it supports C Sharp, Python, a few others. I've written an MCP application. We're going to see that in the demo, but there's the kind of GitHub location so you can inspect it. But it basically, this app has used the C Sharp SDK to write an MCP server that's got knowledge about colors. A couple of things I just wanted to show you before we run to the demo video. APIM is starting to support MCP. So there's an application here that, an example, when you install it, what it basically does, it puts an OAuth authentication layer on top of your MCP server. So, security is important. You might want to protect it with OAuth. That shows you an example of how to do it. But the product team are actually going to make this much more kind of out of the box. So that is coming. What is there as of today is converting, and this was announced at Build, and it's not smoke and mirrors, it's actually there today. If you've got an existing API in APIM, you can just enable it to put an MCP wrapper on front of that REST API. API Center, so that is your catalog of APIs. Now, as of the Build conference, they've shown or released a version that can now have your MCP servers in your catalog. And then the last thing that was kind of at Build was they've now added this new way of putting APIM in between AI Foundry and the backend LLMs. So this just makes it a lot easier. Just a few clicks and it's going to put APIM between AI Foundry and the backend models. Okay, I just want to we touched on this very briefly, A2A agent. So this was announced in April. Microsoft have made a commitment that they will push this into all our products. So AI Foundry was for A2A. And the problem it's trying to solve is that the best agents won't always live in one app or one cloud. So in the real world, you're probably going to want to interoperate with agents in a number of locations across the kind of ecosystems. So A2A is that protocol for agent interoperability. One of the things it's got is a discovery. So what you can do is hit the endpoint of the kind of known URL of the agent, and what it will do is it will return back this card, which has got all its capabilities, authentication rules, the endpoint. So maybe this is a topic for another seminar because it's brand new. It's not in all our products yet, with the one exception, Semantic Kernel is supporting this as of today. Okay, let's roll the video.
Wow. Yeah, let's go for it. I'm conscious of the fact that we are the time is
Yeah,
rolling on, so I think
we've got time for the video. It's about
we've
4
got time for
minutes,
the
I think.
video.
Let's go for it. Over to you.
Yeah.
I've written a simple MCP application with knowledge about colors. It uses the C# MCP SDK. As before, the code is on GitHub, so do take a look later. The color information is stored in a JSON file, but it could have been external, perhaps stored in a database or retrieved by calling some API. This C# file exposes the tool. It's done by annotating the functions. The description information is important as that's what the AI uses to determine what the tool can do and if it should use it. I've also provided support for both MCP protocols. We've got standard in out and then the server-side events. I've included a Docker file to make it easy to deploy. Also included is a client test application. So let's use some MCP tools, including this Colors and Knowledge service. To do so, we shall use GitHub Copilot Agent Mode, which can use MCP tools to get knowledge to help formulate its responses. The MCP JSON file is where our MCP servers are configured. I have the Azure MCP server, which can get information about my Azure subscription and the resources within. I have a time server, which can get information about time. I have my color MCP server. The last one is Playwright server. Playwright is primarily a testing tool, which uses scripts to interact with web browsers. If I click on this button, you can see I get a list of MCP servers and tools. For example, here I can see my MCP color tools. Now let's try this question. I need a palette of 4 colors from the blue family, plus black, and then please add to my colors HTML file so I can inspect. First time you will get a button asking for approval to call the MCP server. You have options to allow it in this session, allow in this workspace, or always allow. We can see it called the colors MCP server to get all of the blue color options, and it's chosen 4 of them, and then injected the code into my HTML file. The chosen blue palette looks good to me. Next, let's try what is the time in Timbuktu. The AI has decided to use the MCP time server, and it's given me the time in Timbuktu. Next, let's try checking out ocado.com, and I want to extract the price of wonky carrots. The AI has decided to use Playwright to interact with the web browser. And the answer is £2.50 for 2 kilos. Now you can run this headless, but I actually had a web browser running in the background. And you can see here where it got the information about the price from. Next, let's try asking about what Azure App Services I have. The AI has decided to use the Azure MCP server. And here is the list in the response. One more question. What is the Docker image name being used by my Colors MCP server? And here is the name location for the Docker image.
Well, again, an awful lot to. I'm just going to stop sharing that, but an awful lot in a short space of time. But it's really powerful that the that agent can find the right service using MCP, and I think but a lot of that kind of goes back to those descriptions, though, doesn't it, Mark? That if
Definitely.
that
You have
effectively
to
it's
you
parsing those
you have to
descriptions,
give
understanding that.
yeah. You have the tool, and the tool could be a function. Each one must be annotated with a description that the AI knows, so it can make a decision. So based on what you type in, it knows which of the tools to use, and you've got to annotate it with the right description.
But having got those, I mean, it's certainly the descriptions you gave your color service weren't, it wasn't like you had to put that in a particularly technical thing. It's just standard language. So, they have to be annotated, but it's not,
Yeah,
it's not like you've got to follow a particular jargon. It's like you just have to describe them
yeah,
properly.
it's indeed. But I guess it's like any of the prompts. The better you describe it, the better the experience is going to be. Um, Can't make it too
Right.
long though, because it all goes back to those tokens. It's in the message that goes up,
Yeah.
so it's got to be, yeah.
Yeah. So I'm just conscious of the fact that we are just about on the hour now, Mark. So is there any? Firstly, I'd like to thank you so much for for putting together the presentation and demos today. It's been absolutely brilliant,
Pleasure.
highly
Thank you.
informative, a great learning experience. But is there anything else that you'd like to just say to wrap up?
Um, Nothing top of mind. I mean, this maybe check out the Build conference because that was a lot of announcements there. The latest and greatest was kept back for the Build conference. There's a lot of good content on there. Um, and no, I've enjoyed doing this. Let's do it again.
Well, I think we've already signposted a few more places to look. I mean, I think this I think the agent to agent is a big thing, but also even just a deeper dive into the MCP and what the potential there is there's some great future avenues to explore because there's, I say, it's just so powerful having just having everything working together. It's yeah, uh, really 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 enjoyed that, and let's keep a lookout for well, please keep a lookout for the next webinar, which we'll do before too long, and we'll hopefully drill into some more of these topics.
Great.
So on
Thank
that
you.
note,
Thanks.
I'll wrap this up, and we'll hope to talk to you soon. Okay, bye now.
Thank you.